Hey, what's up, Ziguanas? Long time no see. This is a special edition of the 30 Days of Z Coding Challenge, and it is special because we're going to go through the code written by Robert. Actually, here, sorry. Yeah, it's reversing everything here in the camera feed. So Robert did an amazing job upgrading the code that I did in live stream sessions, the Tic Tac Toe code. And like you might have seen on the thumbnail, the point of the code is that it is not meant to be an improvement. So the point is not to have something work better in this case, but it's actually to make it more educational, right? So that we can see how Zig can deal with some specific things and what is possible to do with Zig on a project like this. So let's jump right into it. My name is Dusan, and this is about Robert, actually, not about me. So let's see. Hi, Robert. Long time no see. Let's see the code here. I will copy paste it from. So let's first read the Robert's message here. Robert says, hello. Just wanted to drop this here. It should be 100% functional. Did not do super thorough testing. The code is not written to get the absolute best performance out of it. That's what I meant, like when I said at the beginning. It's not designed to be the perfect code, but to be educational. So it's not written to get the absolute best performance out of it. The focus was just to show some cool stuff you can do in ZigZagZoe implementation. It should be easy to understand what is going on, excluding the victory math operations. But that is not the fault of the language here. Okay, and let's see. I will just copy it because here I believe it's going to be more readable if we paste it in the editor here, my favorite one, the online editor. And let's zoom a bit out so that we can go through it. Hi Dev, welcome back. Yeah, long time no see. Then this is the first part. Const rows set to 4 calls. Yeah, by the way, this is so yes, of course, Tic Tac Toe has 3x3 board, but we were discussing in the previous video that just for fun we can make it work in with the dynamic field, so that we can play with the code a bit more. So that's the point. Of course, it's not 3x3. The Tic Tac Toe is always 3x3, but this is something like extension of Tic Tac Toe, right? So now we have here in settings 4 rows and 5 columns, and this is to win. This is how many elements in a line you need to win the game, right? So in Tic Tac Toe it's always 3, but we can also play here because now it's dynamic. We can say it's 4, or we can play with it. So it cannot be more than 4 because we don't have, I mean, it can, but then it cannot be vertically, right? You cannot win. Then this would be an interesting game. So we had symbols, which are, so I believe, let me try to compare them side by side if possible, because I think in my version we didn't have underscore here. So actually I don't have to, I think I remember. So I don't want to switch between screens. It will be probably annoying. So these are, if I'm not mistaken, this is now with 3 characters. In the original version there were only X and O, and the underscore was set here in a different way as an array. Then we have the moves, which is, I believe, very similar to the original one, if not the same. I mean the structure, not the moves themselves. So this is usize. I forgot if I used usize, but this is the usize array. Okay. Then we have the board size, which is rows times columns. Okay, so I don't think I had board size because the concept was different. Let me see what you guys write. Imagine it would not run in the playground. It is strongly based on your version. I didn't want to change it too much. Yeah. Got it. Then I believe we didn't have the, I didn't have this comp time modifier here, right? So this is something that you added, Robert, and it's commented out here. So let's see. Validates options at compile time as much as it can and raises compile errors. So let's see what are the errors. So first there is a check if rows are equal to 0, which shouldn't be, right? So then you have this compile error raised, and it says rows cannot be 0, right? So clear. Then the colons, the same time, it will raise the compile error if the calls are set to 0. Again, for the winning state, it's not allowed to have 0 to win, 0 characters in line. And the similar message here, raised the similar error, the same error, but with a similar message, different message. Then if rows are lesser to win and calls are lesser to win, okay, this is another restriction that is logical. Impossible to reach based on board size. Nice, nice. Then if symbols length, and symbols is this one, right? No, this is moves. This is symbols, yeah. Okay, so the characters. Okay, so if the symbols length is not equal to 3, compile error, symbols must contain exactly 3 values. Yeah, this is also cool. Then we have a check here, if symbol 0 equals, so if the first symbol is equal to the second one, or the first one is equal to the third one, or the first one, the second one is equal to the third one, then you have, again, compile error. Symbols can't contain duplicate values, yeah, because it would not make sense that you have XX, so X playing against the other X. So that's cool to see. Let me see what you guys wrote. Hi, Otto, again. Otto says, that's cool. Robert says, try to raise them. Yeah, I will try definitely. I will try definitely to play with these. And let me just go through them all, at least this part, and then I will play without analyzing before playing. So let's see the next one here, I believe, moves length. So if the length of, if the number of moves, potential moves, is lesser than to win times 2 minus 1. And why this? So because there are 2 players, right? So then for the win state to happen, the first player has to play at least the number of turns has to match the length of the win, right? So how many characters in line you want to have, that would be the length. But because it's not only one player, so there are 2 players playing, so they're alternating. So then it means it will be 1 move less for the second player, hence the -1, because the first player with the third move can make a win. So this is, let's say, the smallest amount of moves you can have. And that's why if the moves length is, so basically if you are trying to have a game here, I forgot to mention, I didn't explain all the code because I had it in previous videos, so you can rewatch, guys, if you don't know what I'm referring to. But in a nutshell, this is a list of moves, and they are indices of the pieces where they will be put. So the first one represents where the first X will be placed. Then the second one is the first O and where it will be placed, the index of it. And then the second turn for X and the second turn for O and so on. So that's why this is the number of moves when it's, of course, to win equals to 3. So then 3 times 2 minus 1 is 5. So this is the smallest number of moves that could make a game legit. So it doesn't promise it's going to be, of course, so it can be a tie after 5 moves, but for sure you cannot have a win if it's less than 5 moves. So that's the point, that you have these edge cases. And again, it's more about practicing the logic and how you can think and how you can raise errors here. So in this case, we say impossible to reach in number of provided moves. Then we have a for loop here, the last comp time error raising. So it goes to the moves, right? So through those indices. Then it makes a capture group, calls the variable move, and then there is a question if move is greater than or equal to the board size. Why? Because if you have, let's say, 9 fields in board, the last index will be 8. So it cannot be even equal to the board size, and it cannot be greater to fit the border size. Then this compile error says that that index is too large for the board size and raises an error. Okay, let's now let's try to break it. First, let's run just to see if it runs normally before I try to break it. Just a sanity check. Okay, perfect. So now I will play. Let's cause the first error. So this should happen in compile time, right? So before the board is drawn and before anything else happens. Let's do the first one, rows equals 0. So let's do that one. Let's break the code. And we got our error. So rows can't be 0. So the first one. And you see here, Robert used the escape sequences for quotes, the literal ones. So you can also do this with the U, right? With \u and the code. But this is, of course, easier if you have one of these special characters that are supported with this shortcut version. So this is perfect, yeah. Then let's test the next one. The calls cannot be 0, so I will undo this one, and now I will make a colons 0. And of course we get an error. Calls can't be 0. And it's compile error. So the one that is specified here. And they're all matching, right? So then the next one says that the win situation has to also be not 0. So the number of characters in line, in a sequence, let's say. So it doesn't have to be, basically they're all lines, diagonals. And yes, of course, to win can't be 0. So this will raise an error as well. Then we have the next one. So if rows is lesser than to win and columns is lesser than, so only when both are less, then let's do that. So let's make this 6, for example. Now they're both less. And it should raise, right? There we go. So to win, impossible to reach based on board size. So exactly what we were expecting here. And let's now decrease it so that it's not both of them, but that we have one of them equal. So let's say calls, because it's larger, I will not change it. So let's say 5. So now it shouldn't break, right? So because this is a legit state, so it should run. Yeah, okay, perfect. Let me see what you guys wrote. Andre says, should have used splat for board variable initialization. For the board here, which one you... okay, I understand, okay. Let's see what Robert responded. I like to have it ensured its compile time constant, and I wanted to show the star operator, so the multiplication of the, so this is probably after in the code. I haven't reached that part. So if I'm not mistaken, that's the one that sorry, multiplies extends the array, if you will. So it will multiply, it will repeat a part of it some number of times. And let's see what else Robert says. Same like I could count last moves differently, but I wanted to show overflow on the flow math. Yeah, this is also something that I haven't reached yet. So we'll see that. The next part is here. So it is about the length of symbols. So these here. So let's make them larger than 3. So let's do anything, doesn't matter what it is. Now we should get this error. And there we go. Symbols must contain exactly 3 values. So let's try smaller. Now let's try to delete the third one. And of course it will break. Yeah. Okay, perfect. By the way, let me just add this link to the description of the video, so you will not see it because it's on my other screen, but I will add it just in a second. Here, where are, okay, here, the description. So I've added link to a description of the video so that people can find this code before I forget to do it. Okay, so let's do the next one. So I reverted this part here, and I will see what is the next one here. So they are trying to see here, the code is trying to see if there is a repetition here. So they have to be different. All these three characters, they have to be different from each other. So if I make any of these the same, should break the code. Let's see. Now we should get the first and the third are the same. And it says symbols can't contain duplicate values, of course. Now let's do, for example, first and second. So let's do 00 just for fun. So this should break in a similar way. Actually, in exactly the same way. Yeah, can't contain duplicate values. The symbols cannot. And then the second and the third are remaining. So let's do like this. Yeah, perfect. Then let's see the next one. This one. So if the length of the moves array is lesser than this 2win times 2 minus 1. So because now we have 2win, so let's play with 2win equals 5, and then I will revert it to the original 3. So in these times it should be at least 9, right? So this is 5, this is 9. So this should be okay, shouldn't break. An error occurred. Okay, I will see. So maybe there is something down that causes the error, some inconsistent state, but it's not a comp time problem. This is not causing a comp time error. That's the thing that we can for sure see. But if I do this, if I delete and now there are 8 moves, now we should get a compile time error. Not the runtime one. Yeah, so this is a compile time error. 2win is impossible to reach in number of provided moves. So this is for 5. So let's do the same for 3. So now, of course, if I do it in this way, it will be fine, everything fine. But then if we make it less than 5 elements, should break. So 5 should be fine still, except for the runtime error that we will get, but no compilation, no compile time error. Yeah, okay. And now if we delete the 5th one, now we should get the compile time error. Yeah, perfect. So again, 2win impossible to reach in number of provided moves. Okay, then let's see. I think the for loop is the only remaining thing. Yeah. So in this case, it's just checking if the moves, if the indices of the moves are greater than the size or equal to the size of the board. So let's see the board size. In this case, is going to be 4 times 5, so 20, right? So this cannot be greater than 19 then. And let's see how, I will just reduce it to make it smaller. So let's say 3 by 3, so it's 9, it's easier to count. So now it cannot be, the index, the largest index cannot be greater than 8, right? So let's see, one of them, yeah, my mind's shifted. I wanted to count them, but it's not the point about the length, it's a point about the index, the number of indices. So this should break because of this 9 first, then it would break also because of 14, but because here the first one that will trigger the condition to be true and cause the compiler to be raised is this one, sorry, this one here, number 9. Yeah, so moves contain index too large for the board size. And if I change back to 5 times 4, it's 20, and we see that there are no indices that are greater than 19, so it should be fine. Yeah, and let's see now if I say 20, for example, should break, right? Yeah, and if I say 19, it should be still fine. Yeah. Okay. Let me see if you guys wrote something. Sorry. Sometimes I forget. The next comment that I haven't read, I believe, is this one. Robert says, Zig has great ability to describe edge cases. When you expect something to happen, you can make a compile time checks that this thing is correct, or debug build only asserts to validate state at runtime. Okay, okay. There, this is cool. And those debug build asserts will not only disappear at release fast small builds, but the optimizer actually uses them in its heuristics. Okay, that's cool. Just saying there could also be a check that there are no duplicate moves. Yeah. Yeah, that would be also another idea. But the original implementation handled it differently, so I kept the way just a bit better. Yeah, yeah. Understood. Okay, so now let's take a look at the rest of the code. So the next thing here is the board. And the type of the board is a U8, so array of U8s of this size, the board size, which is calculated above here, right? So, and it's a constant, so known during the compilation time. Then let's see the comment. You can store type of board for further simplified use. Okay. Then there is this check winner function, the first one. Let me see just quickly how many. So you kept the, I see that you kept all of the original functions, the draw board and check for winner. And then there is a main with the main game loop. Yeah, okay. So let's do first the check winner one. So it takes the board. In this case, it's called with the lowercase b. And it's a pointer. It's a constant pointer to the board. So this is that board with uppercase B. And then there is another parameter called change at, which is a usize. And it returns a boolean. So true for winner found and false if not otherwise. Then we have 3 constants inside of the function defined. Change draw, which is change at divided by the colons, so the number of the colons. So I will see this one when it's called, what it actually represents. So we can actually do that now just to have the context, just to jump where it is called here. So it's the move's last move. So the last move is also, I believe, the index. Let's just double check. Yeah, so it has to be the index because it's referring, I don't want to like spread now too much. I want to go back to the win check function first, but because moves is an array, right? So if we scroll up here, moves is an array, then it has to be that this is an index of an array. Then we know this is change at usize, it's an index of an array. Then we take that index of an array, sorry, here, change it, index of an array divided by the number of the columns. So basically I will open up the paint just to visually represent things to people. So we will have in this situation, what was it, 4 by 5 or 5 by 4? I already forgot. Give me a second. Where is my editor here? So it was 4 rows and 5 columns. Okay. So let's simulate that here. So 4 rows and 5 columns. My monitor is going crazy. So it's turning itself off. So that's why I have to pause. Something is weird. Okay, so 5 columns, 4 rows. This is the board that we have currently. Then let me see the rest of the code. So we have change at, which is the index, right? So let's say just I will randomly check an index. So let's say the index is I. Let's say it's, let me just make it somewhere here in the 3rd row. So here it will be 9, 10, 11, 12. Let's do 12, for example. Just, and let me make this a bit larger. So let's say the index equals to 12. Okay, so then it should be here. This is 12. Let me double check. 4, 9, 10, 11, 12. Yeah, it should be like this. So then you have this 12 divided by the calls. Yeah, the number of the calls. I just wanted to double check to make sure. So the number of the calls is 5 here because we have 5 columns here. So if you divide this, you will get, this is like, can you remind me please, this is integer division, right? In Zig, if you have 1/, it's still an integer division, because in Python 1/ is regular and this is an integer. So I believe this is integer division, right? And let me see what you wrote, sorry. Robert says the thing at line 42 is just a type shortcut assignment. Let me just double check what you refer to here. Okay. Okay. So this is the type. Okay, assignment. Shortcut, like you said, yes, it is an index. This is about the change at. The Robert says, confirms that this is an index. The last move, YouTuber 11, hello, welcome. Yeah, you caught me live. Okay, so then let's do jump back here. So I believe this is an integer division. So it means 12 divided by 5 will be 2. So this is what we get. And here we have 2. So change the row equals 2. So it is the index of the row, which makes sense because the first is 1. The first is 0, the second is 1, the third is 2. So it is exactly matching what we have here, because we have in this row, there will be a change. So this is 0, 1, and 2. So exactly what we get here. Perfect. And then let's see the next one, change at modulus call this time. Then let's do, so in this case, it will be 12 modulus call, rows, right? The number of rows. So wait, just want to confirm. Modulus call, sorry. That's why I confirm that I don't make a mistake. So this will be modulus 5. And then in this case, it will be 2 again. So I picked a perfect number by accident. But okay, in this case, it will refer to the index of the row, which by accident is the same here. So 2. Now this, so I will make it a different, let's make this a square. So this square here, and then I will make it also here a square. So this is an index of the column. So we have 0, 1, 2, 3, and 4, and here it will be 3, will be the last one. So we have now our row index, and then we have also here the column index. what we have so far, and then let's see what is next. Place tile, board change at. Okay, so change at is the literal index in this case, because just to remind you, the board is one-dimensional array, so it's not two-dimensional, so that you need two coordinates, two indices, but you just need one. That's why 12. So it is not stored like you might think in this way, that you have one huge array that contains, in this case, 4 smaller arrays, and that these smaller arrays are all 5 elements long. So it's not the case. It's just like one big array that has rows times columns, in this case 20. So you have something like the first here index, then the second, and so on, and the last one will be 19. So this is the case. That's why this is the thing you use to change the board here at that given index. Let me see what you guys wrote. Robert says hi to YouTuber. And then Robert says unsigned integer division, so it does floor division. Yes, thank you. Then Math Madness. And no interesting language features here. Okay, horizontal label. So labeled 4 goes from 0 to win. So the win is, just to remind you guys, it's how many things you have to have in a sequence, in a line, if you will. So you try to see if you have 3 in a row, or 3 in a column, or 3 in a diagonal. So this is why. So in this case, it's 3. So you have 0, 1, 2 are the indices that you use for 4, which will take the 3. Why this is important? So now this is, like Robert says, a bit of math madness, because if you set on this board size, let's say this is 5 by 4, right? So we have 4 rows and 5 columns here. And if you set the win, so I think I set it to 3. I already forgot. Give me just a sec to double check the win. Yeah, it's to 3. 3 in a line. So it can happen like this, or like this, or like this. This is all 3 in line in a row. So unlike Tic Tac Toe, where you cannot have these weird, not weird, but let's say harder cases. So in Tic Tac Toe, you are always from one edge to another. So this, this, and this. You don't have additional check here. But this is why Robert says math madness, because here you have to cover all these cases. So in this case, we have 3 checks in a row, and it would be more if you had more columns. And in general case, you will want to know how many things you expect in a line, in a sequence, to cause the win, so that you know where to stop checking these things. So this is the last time in this case. Why? Because it's 3. So these are the last 3 potential places where you can have the winning situation, and you cannot test from here, for example, here, and then the next one would be outside. So in this case, because we use one-dimensional array, if you actually checked for the next index, it wouldn't be outside of the board. In this implementation, if you had two-dimensional array, it would be outside of the board. But in this case, because it's a 1D array, then you are actually checking if you ask for the next here. So it would be in this case 5, index 5. It's here actually, so in index 5. So you are then asking if you have these, for example, x here, and x here, and then you say, yeah, it's a winner, and it's not. So that's why, for this reason, you have to be careful in this math part, why you have to stop here, so that you don't check here, that you stop here. So this is the last time you check these indices in sequence, because otherwise you would have a different situation, not correct one. So that's why here Robert says math madness. So we don't have to do this math part here. I did go through it in the last video, so if you want, you can watch that one. If you want me to explain this in the future, you can write in comments, and then I will maybe do a special video about the math aspect of it. But in this case, it's not that important. It's more important that we focus on the Zig features here that Robert used. So this is a feature of Zig that is more important. So Robert used the label to label this for, which then means he can do something like this. So it can continue this for. So this one is not labeled, and this one is labeled with this in the identifier. So here, when you say continue, you're continuing this main outer loop, not the inner one. So that's a difference. That's what is interesting here. And let me see what you wrote here, Robert. Only interesting thing, outer loop continue. Yeah. Yeah, so capture groups, I did use them in the previous one, so I will not spend time. So if you guys want to look, you can see the previous video in this Tic Tac Toe series. For that one, so they are now repeating. So right, so they are just like labeled differently. So this one is labeled horizontal. Here it's labeled vertical, but the same logic, right? The same principle. And of course, the math is different. So like I said, we are not going to spend it. This is very interesting. I love this part, but I would just like to go through the zig part. Then diagonal, the third label, sorry. So again, continue that one, and diagonal 2, which is continued here. And then the logic of this is pretty much the same. I mean, the main higher level, let's say high level logic, sorry, of the function is that if you find in any way, like horizontal, vertical, and any of diagonals, if you find 3 matching character symbols that are next to each other, then you stop there, you return true, and your function will return yes, there is a winner. And if you pass all these checks and you naturally reach the end of the function, then it must be that there is no winner. So that's why you return false. Let me see if you wrote something, guys. Robert says, your original implementation was with single array. I just followed the design. Thomas, yeah. Yeah, thanks. Yeah. I've noticed that you haven't changed the original design. And you guys can try on your own if you want to make this two-dimensional array. It would be then different. So try to adapt this code just for fun, for testing. So I will not do it because I have experience from different languages, and this is more about math logic than the language itself. So the harder part were like, for example, I think in the second version of Tic Tac Toe, when I struggled with the inputs for this or the other method, I forgot which one, and it was different. So maybe I will not even recognize it. Maybe the draw board, actually. Give me just a second to see. Yeah, it's different now. So you're passing a board. In my version, it was a bit different, and that was the part that that I struggled with because it's Zig syntax, and I wasn't sure how to use arrays and pass them as, or was it an array, or it was a constant slice? I forgot already. So yeah, it was a constant slice. How to pass them? So this Zig part, the Zig specific part, was hard for me. You can see me. You can watch me struggle at the end of the, I believe, the second Tic Tac Toe. Where I struggled, so that's why I say I'm going to skip this math part, because and also this let's say remaking this code into two-dimensional array, because that would be just, for me, it would be an easy part because it doesn't involve Zig knowledge. It's more about common logic and general programming knowledge. Okay, let's see the next function, draw board. So I see that you changed this one as well. Now it receives the board, or maybe it wasn't the board, it was different, I forgot. But anyways, in this case, it's a pointer. It's a constant pointer to the board, right? So the board is this type that Robert created here. So this would be then, the board is like the alias type, so maybe not by, so I'm just like trying to understand what's the correct term that they use. So I don't know if they say alias type only if you don't change any generic type, let's say, but because here you are using the custom size, this is why I'm like not sure if you would say this is the alias type or not, because you are applying something. So you're not just like saying this equals something that is, for example, like this. If you were to do this, then this would be an alias type. But in this case, I'm not sure if the official term would be alias type in Zig, or let me see what you wrote here actually. For the simplified use, you can store type of board. Yeah. So yeah, that's the part I'm not sure how to call this officially. I understand what it does, but just like struggling with the name. Let me see what you guys wrote. YouTuber 11 back to work. Oh, hopefully it's a fun one. It's a fun work, or at least that you will make it fun in a way, one way or the other. Let's see. Robert responded, yes. Alias the type. I aliased the type of array with size of board size to board. Thanks for explaining. You can replace board with the board size you ate and it will work the same. Just an alias. Yeah, thank you. So then let's see, there is a pointer to the constant pointer to the board. And then void is the return type here, because the draw board should just draw, right? It doesn't need to return anything. Then we print the board. So this part here is from this line. Then there is a loop that will dynamically do this one, right? So the board is one part of the puzzle here, one piece of the puzzle in the for loop, and the other one is this one, which will create the index, right? So the first board, so the for loop will take elements of board one by one, so the characters that are stored in the board one by one. So this you can imagine in the background saying tile equals board square bracket 0, tile equals board square brackets 1, and so on. So this is the tile itself, the character, and this square brackets part, like what is the index, is coming from here. So you generate the indices from 1 until the end, and that will be the I. And let's see what Robert commented. I'm curious to see why not 0. Let's see. Notice you can count index from any arbitrary value 1. Let's see then. What did you do with these numbers? So the ending is a constant of U8 type, and what it will get depends on this condition. So if this is true, it will get \n, so it will go to the next line. So this is the case, and otherwise it will be space. So either after printing the character, that's basically what it says here. So you either print a space, or you go to the next line. Yeah, nice. Then the question how you determine if you're going to do one or the other is answered here. So if the I modulus calls equals 0, so if you, when you divide with the number of columns, if you get 0, then it's time for a new line. So 1, 2, 3, 4, 5, you have 5 columns, 5 modulus 5 is 0, so it's your sign to go to the next field. And yeah, basically, yes, you so now I understand why you took 1, because you don't care. You just take. So this is not what I said. I made an error. So I was just like trying to explain, but then I actually complicated things probably, because this is actually taking the characters from the board. It doesn't need an index. I was just trying to explain in a way that is actually wrong. And this is just used here for this I. So they're not related directly. I mean, the logic is such that you kind of have the logical background connection between the two, but they are technically not related. So you can say, like Robert says here, you can say 1000 or whatever, and then you will change whatever, then you will change the logic here. And then you print CC. So you format it as a character. And what do you print are these things: the tile, which comes from the board, and the ending, which is created here as either the new line or the space. Okay, perfect. So, and in this case, it's interesting that you have everything happens in one print, right? So you don't have to do any if conditions. Like I think I had an if condition afterwards or something. I forgot already. So my solution was a bit messier. I believe, if I'm remembering correctly. Then let's see, at the end, then you do one more line. So this is just for the space here between the turn 1 and, I mean, the turn, whichever the turn is, and the board itself. So this is coming from here. Let me see what you wrote, guys. What was the last time this is the comment that I haven't read. Why not 0? The logic required, Roberts explains here the part. Logic required +1 if it were counted from 0, so it is just simplification. Yes, understood. And showcase, you don't have to count from 0. Nice, nice. It still goes through the whole board. Yep. Nice, nice. So correct me if I'm wrong, but this, if I were to say 100, so it will still depend, the number of iterations will depend on the length of the board, right? So it doesn't actually go until the end of the board, like it doesn't think of it as an index. It's just like going to start with this number. It's going to be generated the first, and then it will go until the end, meaning like whatever is the length of the board, that's the total number of iterations you will have. And then if you have, for example, in this case, I don't know, 20. So if you say 101 is the first one, then the last one will be 120. Right, yeah. Thank you, thank you. Let's then go to the main function. So the first thing that happens here is creation of the variable last move. And let's see what happens here. So this is a literal, which is comp time int, converted to coerced, if you will, to usize with this built-in function. So now you demonstrated how you can coerce. And then I don't know what this minus modules means. Let's see, you wrote probably here. I just want to see what else is written. So minus modulus 1. Let me see what you said here. Real cool. Basically sets to usize max value with underflow subtraction. There is also more general function in std for this. Okay, let me see. Let me try to understand. So this is the easy part that I understand. So this will convert 0 to usize. So usize is architecture dependent. So it will depend if it's 32 bits, 64 bits, depending on your architecture. It will be unsigned integer. Then you say minus modulus 1. Then sets to usize max value with underflow subtraction. So this is then obviously underflow subtraction to usize max values. It sets it. Okay, so if you subtract 0 by 1, did you make as usize 11111 binary, right? So am I assuming this correct? So if you have 0, because it's unsized integer, 0 is the smallest smallest value that you can have, no matter if it's 64 bits or 32, it will be 0 will be the smallest. And then if you reduce 1, it will then go overflow and go around to 1111, the largest one. And let me see what you wrote. What happens when you make 0 minus 1 on none? Yeah, so I think what I just said, I'm just like not sure this operator. So if you were to do it without, so if you were to do this, then it would be a compile error, right? Something like that. So it will not allow you to do this because that would be an overflow. But this is how you call it, wrapping. How you call it? Underflow subtraction. Okay. So this is just like going to cycle around, if I'm not mistaken. And let me see what is next. Here you have these 2 pointers, sorry, 2-star operator, where you have let's see what you do. So you create a variable board of board type. You wrote something. Give me a second to see. If you were to make an underflow in Zig with normal minus operator, it will panic. Yeah. So that's what I guessed. So you need to specify when you want for it to happen. It catches a lot of bugs. Nice. So can I do also plus modulus to go the other way around? So from 1 to 0. Is it plus a modulus or some different operator can I use to do that? I remember that I went through the operators maybe in the second video, but when I saw these, I just like went over through them because I didn't understand how they work, just from the explanation, and then I wanted to see them in action somewhere, but then I never saw them in any examples. Robert says this is extremely common bug in low-level programming. Oh, just wait. Yeah, remember these kind of things. I played with them with the solidity. So in previous versions, you didn't have safe met functions, so you could cause an overflow, and then you can make. So if someone, so theoretically, of course, nobody allowed this to happen, but theoretically, without some protection mechanisms. So imagine that, like, when you have balance of 0 of any crypto, doesn't matter, like doesn't have to be Ethereum, the native one, but any ERC20, and then you say like minus 0 minus something, and then you actually get the maximum value. So you suddenly have like full wallet of something. So this is, of course, it was prevented. There are mechanisms to put this in place, but theoretically, if you had some, let's say, a custom smart contract that you want to use for some, whatever, it's like the transferring some value, whatever, like you have, let's say you create a smart contract that will store the balances of your users that pay each other for whatever services, doesn't matter. Then if you write the logic in that way, in an unsafe way, you can easily make this it's just like a variable in your code, and you can easily be hacked in this way that someone says, okay, now I have like 1 billion of something on my account, and then they call if you allow them, of course, if you do it in this way, then they would be able to just withdraw the money using some of your function. If you did it in this, of course, you don't want to do it in this way, but it was something very important because it's about money there, literally, like you're coding money. But people use like OpenZeppelin. There is this group of guys that are creating most common smart contracts that are used by like 80% of the time. You would need to use something like that. They already have a bunch of these smart contracts that you can build on top of, but they changed it eventually. So now in Solidity you can do the safe math. Robert says there is plus modules in the code. Sorry, I was jumping ahead. I didn't see. Sorry. That answers my question. And let's see what else Robert says. My most common usage for overflow operations is fast random number generation based on bit masks. Interesting. It's not crypto safe, but great for games, for example. Yeah. Sometimes you don't need a cryptographically safe thing. If it's not about the money, if it's just for fun, I mean, maybe some people would just like to hack it like they do Counter-Strike and wall hack and things like that, but not the point. Okay, so here board is, so it takes symbols, the third, sorry, which is underscore, right? So the underscore character, it makes it an array of U8s with size of 1, and the content inside, literally, like if you want, this is equal to basically this under quotes that are double, not single, so a string, literal. Then because of this, you're multiplying by the board size, so you're technically doing this 20 times. So you have 20 times this character in an interesting way with this operator. Let me revert it back. Okay, let me see your comment. Populates board with empty symbol. Yeah, nice. I wanted to do this, but I completely forgot later. My mind drifted. Draw board, call to a function that we just went through a few minutes ago, and it passes the reference to board because here the board needs a constant pointer, right? And this is the address of the board. Then we have a for loop that starts from 0 to board size. This time the capture group has only one element inside, so only the turn. So you're generating the turn, the number of the turn here. And let's see what happens. Current player is a constant. And then you take from the symbols, which is XO underscore. So you take the turn, do the modulus 2. And that will be, so this is also interesting because you are dealing with 3 elements, but you don't care about the third because you're doing modulus 2, you're alterating between these 2. So this doesn't bother this code. It can be any number of characters after, because you're doing modulus 2 and not more than 2. This will never be taken out. So you either, if you have 0, you will have X. So if the modulus is, if the turn is, when you divide by 2, the remainder is 0, you will take this one. And otherwise you will take all. Right, so let me see. Here, right? So then you take that specific turn. So you start with 0 so that you have X as the first one, the first character. Okay, then you print the turn and the player's character. And then of course here you increase by 1 because your first turn is 0. So human number, ordinary number is first, not 0th, right? So that's why you increase by 1, and then the current player, which is the correct symbol from here. Then you have last move, which was defined here, right, as the maximum size of use size, maximum number that can fit in the use size by the architecture. And then you are reassigning the value here, right? So let me just see. Here you're setting to the max, but here you are going to reassign the value to it depending what for loop does. And let's see what the for loop does. So, so now you hear overflow. Nice, on the other side. So you take the last move. Oh, I didn't even know that you can do this, that you can assign dynamically with how it's called, the range here, how you call this. So you create you generate numbers from 1 to the length of moves. So 1, 2, 3, 4, and so on until the length of the moves with this code, and then you are increasing this by 1, by 2, by 3, right? So if I understood correctly, this is where like interesting syntax. And then you take the move, you capture it. So this will be the number of the move, right? So then let's see what you have commented here. Zig for loop is expression. Also notice the overflow addition. Yeah, that's the very cool part. Let me see what you wrote. Andrei first says better way to do it is var board equals splat. Yeah, you mentioned this before. So splat to take the symbols 2, so means the third element, so underscore the same thing, and you have the array of 1 length, and then you split it. Okay, so the split is, if I remember correctly, is making an array out of 1 number, and it has the same value. So if you have, for example, 2, it will end 1, 2 in an array. Sorry, not necessarily doesn't have to be an array, but if you have a scalar value 2, and then you split it, it will create an array of some number of 2s. So it will be 2, 2, 2, 2, 2, 2, 2, 2, and so on. Yeah, I remember this from the it's interesting. So I'll just try to copy paste just to show the people, because sometimes people don't see the chat, the live chat comments. So what Andre is saying, that you could do something similar here. Instead of this, that you could do something like this, that you can say varboard equals, and then this instead of this part here, which will produce the same result. So again, splat built in. Here, this will take one element, which is, so here symbols, it's our thing from the beginning, the 3 characters in as a string literal. Then because you say square brackets 2, it's going to be 0, 1, 2, so the underscore again. Then if you, so I went too far. So this is your underscore, so you're having one array of U8s of size 1, which has only one underscore. And I didn't even know, for example, the day before, a few days before, when I read about splat, I knew that this can be done when you have a scalar, so 2 as an integer can be then split into an array. So let's say you have 2, and then you make array of 9 2s or 10 2s inside. But I didn't know that you can have the element, the array with one element, and do the same split. So this is then even better. Built-in is much more flexible than what I initially thought. And there is this reduce, that is that's doing the opposite, right? So a different thing. So I will just leave it commented out here. Just wanted to show to the people another flavor and playing with built-ins. Nice, nice. Thanks, Andre. And then let me just read what else you wrote. So then Robert confirmed afterwards. Then Robert says, no, it is less moves, plus modulus 1 moves length. You just don't have to put the braces there. Then Andre says, split just in first size of array, so there is no need to specify twice. And then Andre says, plus modulus 1 here is also just educational. Since it's impossible to have 2 to the power 64 moves. Yeah. So this is we are playing with Zig limits and trying to be aware of them, practice them. That's the idea. Thanks for explaining. They just won't fit in memory. Then Robert says, no, it's necessary. The last move on first iteration is set to U size max. So you need to have on first go through something. Yes. Yes, there is this. Where is it? I went too far here. So because you use it here in 4, you have to start from something. Okay, then let's see the if condition inside. So if board moves, so the index of the move equals, and then you have underscore here. What you do, so this proves that you are trying. So the point of this logic is to put the X or O in a place which is empty, which means underscore. So that's why you test here for underscore. So if the board where you potentially want to move, so this is getting the move from the moves, so from here. So let's say you're trying to place, this is O, right? XO, XO. So you're trying in the second turn of O tries to place O in the index 4, which technically means here, index 4. So here O wants to play here. And of course, if X or O are already there, you cannot do that. So it has to be empty, and empty in this case means underscore. That's how we set things up. Of course, unless you change here, then you can say E for empty or whatever. But in this case, it's empty. But anyways, it will be the second, the third character, the index 2. So that's why here, where it is, here we check if index 2 from symbol. So if underscore in this case, so only if the field is empty, then you take the same position, is then safe to update with the current player's character. And then you break move, return value from loop expression. So here you had this move, which is an index on the board and you assign it to the last move. So you say last move equals 4 in this case, for example, if it's the second turn of all. And then you go here else, return error, not enough moves provided. This is also interesting. So if you reach this point here, if this else, it means that you don't have enough moves. We ran out of moves because here you make sure that you have enough of them. I mean, you have to have enough of them. And then draw board, you again draw the board. So this is state before. Then in the turn, you change the state. So this is only for the first time without outside of the for loop. You print this only once, an empty board. And then every other time it will be after you make a move. Okay, then if check winner, we call finally the function, and we pass the board address of board and moves last move. So not the index, but the actual. So yeah, actually this is an index, moves square brackets. Something will give you an actual index where you place the last move. Then we print the winner is. So this is of course if this is. When we call this check winner, if it returns true, it means it detected 3 pieces in a X or O in O's in a sequence. Then we have winner, and we know the player that is currently playing. So we know this is X or O depending on the condition at the beginning. So current player, we determine it here, what we did before. So then we have here, it will be here, this will be X or O, and it will be injected here as a character. So not as a number, but as a character. And then you break here. Implicitly, it's a break void. So implicitly, yes. So it's like this, right? I forgot if it's with the dot or without dot. I think without dot. To explicitly say it. Implicitly, so to explicitly say it, and this is implicitly a break void, which means expression returned and else is ignored. Okay. And then you have else for a different thing, so for the for. So it's not the else for the if, but else for the for. Else print it's a tie. Again, loop is expression. This triggers only if it does not return. So if we don't have this return statement here, right, that's the only one, then we are going to have this else triggered and it will be a tie. Yeah, this is also interesting. And then we print game over. Nice, nice, nice. As you can tell, guys, I haven't looked this code at all, so I wanted to do it online. So I actually started when Robert wrote me a message on when he made an issue on GitHub. I kind of started to read the first part of it, so I started to read this part here. Then I remember, oh, I don't want to do this offline. I want to do this online, so that I'm not familiar with the code at all. So that was the idea. That's why I wanted to do this in front of the camera so that you can see my reaction and everything. And of course that Robert can provide some details about what he meant, but additional maybe information about some pieces of the code he did. Perfect. Let me see what you guys wrote. Robert says it's possible to do without any overflow. The logic would be a different then. Yeah, it's always like not one path. The empty break returns void. The break is for the for, not if. Give me just a second to see. Double check. Oh, it was lower. Yeah. So this one breaks the for, this one here. Understood. So this is breaking that for. And then it will not reach this else. if it's broken, because it returns void. Yeah, it's kind of weird situation, but yeah, makes sense. Let me see what else Robert wrote. The break is, yeah, okay, that's what I read. So it returns and else is ignored, the type print. Yeah. That makes sense. Okay, perfect. Thanks a lot, Robert. So you did amazing job here to, at least like in my mind, I have now much more clear understanding of some concepts that I haven't used. So all these overflow, so I've never seen the examples in the docs. Maybe I ran over them without noticing. It's possible, but I haven't seen them that I'm aware, at least. So this is also very cool. Thanks also, Andre, about explaining this part. So I believe that Splat can only deal with the scalars, not the array of size 1. So I wasn't aware it can also do this. So this is also very cool. Yeah, so this was very interesting session. And I will add it definitely to the playlist. I have this one playlist about Tic Tac Toe. So I will definitely add this as the 4th video there, because I think it's very interesting and useful for the people to understand these additional concepts of Zig that were maybe hidden for some of us. Let me see what you wrote, sorry. Just saying it's a bit of overkill. No, it's completely useful code. So the point is that we learn, right? So all these concepts that are seen by I've seen some of them for the first time, and I believe some other guys will also will watch this video will also have the same opinion. They will find some of these things very useful that they never seen before. So again, I will repeat, I've added the link to this, the Robert's post on GitHub, in the description of this video that I'm streaming right now, so you guys can see, so you don't have to rewatch the video and try to catch as I scroll. So there is a code, it's in the comments already, so you can see. Let's see what else Robert wrote. The code could be much simpler. There is a lot of complex logic handling edge cases which could be made more explicit. Yeah, but then we wouldn't learn, right? Anything. We kind of combine a lot of features together. Yeah, that's great. That we covered a lot of things that we went through the docs. Andre says Splat was originally used just for vectors, and vectors only work for scalars, but now it works with arrays, so it works with anything. Oh, cool. Nice to know. Yeah, this is so cool. Okay, thank you guys. So I think tomorrow, I'm sure tomorrow I'm going to continue with what I mentioned before. So the regular day 20, which one? I forgot. Let me see. I forgot what I did 1 hour ago. So 24, I believe, just to confirm, because my mind is now, there is no more space for anything. Yeah, 24 was, so tomorrow is 25. So tomorrow I will continue with the regular day 25. So I will do only one stream tomorrow because I did 2 today. So then the special edition, like summary special edition after the 25th day, will be the day after tomorrow. So I will do probably first the summary and then day 26, the day after tomorrow. But tomorrow I will just do the regular 25th day of playing with Zigs. I'm tired already. Playing with Zig, and that's the plan for tomorrow. Thanks one more time, guys. Let me just see before I go at the comments, and I can go to the outro part here while we're in the comments. Andre says scalars, I meant floats, integers, bools, and primitive types. Yeah, I understood you. Thank you. Robert says, hope I didn't hog your schedule. No, it's perfect. Like, it's amazing that that you spent your time and did all these things here. New things that improved my understanding, and I believe other people who are watching that are not so experienced, that don't know these things, they for sure had a lot of high quality information here. Thanks one more time. Let me see what you wrote. Sorry. Also, when native setup, have to do it in the following 5 days for sure. Bye guys. Thanks one more time. Thanks a lot. Namaste. Thank you. Bye.